clear. It's really odd. Scans in the letter expected, and here's my little nested if statement. If letter expected is A, print that's optimistic. And then otherwise it says sounds good. So this is a nested if statement. All right. So we have an if inside of it, one if statement. We have another if statement. Okay. So you can nest as many of these as you want inside of the other. So if you didn't take it as a letter grade, and if you didn't take it as a letter grade, it'll skip all that stuff inside that bracket. It'll go down here, and whatever. You get the idea. Not too complicated. And it's like, okay, else if to take your audit. So this is a good use of if else if. You have a bunch of you have a defined number of options you want to do for one question basically. So you're asking, okay, is what they're doing, is it a letter grade, is it an audit, is it pass, no pass? And then if it's none of the above, I print invalid, what the hell, So this is a good use of if, else if, and then else. Okay? So else is going to take care of anything else that isn't one of the options above. So many times it's like, okay, obviously it wasn't what I was expecting, so this is how I wanted to handle it. As pertaining to your homework, you guys are doing something where you have to either treat something as an int or a double, and you have basically four options, right? And it's like treat things as both ints, int double, double int, double double, right? If, else if, else if, else if, all right? Sure, you can have multiple ifs, you can have a bunch of if statements and it'll work the same. However, it's a little bit inefficient, and sometimes if variables change, you might get unexpected things happening. The important thing to note is when you're doing if, else, it's only going to execute the first one that it encounters. So even if for some reason this was, this third one was true and the first one was true, which it's not going to happen in this case, but say you wrote a program so both the first and third case were true, it'll do the first case and it won't look at it anymore. Okay? All right. And you guys should have known you can do multiple conditions inside your if statement. So you can do something like, okay, if answer is equal to letter, and I don't really have any other variables at this point, but answer equals something or other. I don't know. Anyways, you can have two things, and as long as the entire thing inside this evaluates to true or false, it's okay. Now, what you can't do, what doesn't work, and I saw a lot of people trying to do this, is to say, okay, is answer equal to letter or audit? Or maybe I want to create an if statement where I want to take care of cases where both it's equal to letter or audit. Like for instance, in your homework where you want to take care of lowercase and capital case letters. You can't do this. C isn't so high level that it knows what you mean. How this will evaluate, it'll say, is answer equals letter true? Okay, let's say that it is true, 1. Or audit, whatever audit is equal to. And audit is equal to 3, which is actually true, right? Because true is any number that's not 0. So it's going to be whatever this is. This will literally evaluate like this. Answer equals letter or audit. Okay? So you need to be very careful and do things like I did with one separate one over here and one separate one over here. If you want to do if answer is equal to letter or audit, you need to say answer is equal to letter or answer is equal to audit. Anyways, you guys get the idea, right?
No way to shorten that up, It should be two separate ones.
It has to be two separate ones. The way, like I said, the way it'll evaluate this. If you try to do this, the way that it's going to evaluate is answer equals let's say answer is equal to odd. Let's say answer is equal to pass no pass. Okay, and you're like, okay, I'm trying to design this so that it picks up both cases for letter and audit. So I'm like, okay, this should take care of it. If answer is equal to letter or audit, what's going to happen if it's pass no pass? It's going to say answer equals letter, false, or audit, which is equal to 3, which is actually true. So it's going to be false or true, which is true. So this will actually evaluate the true. This line will evaluate the true if answer is equal to pass no pass, because the way the program is going to see it is it's going to see it like this. It's going to say, okay, false or the number 3, which will evaluate to true. Anything that's not 0 evaluates to true. Does that make sense? Anything that's not 0 is true in C. 0 is false, all other integers are true. So if answer is equal to pass no pass here, this is the first if statement is going to evaluate to true in this case. Does that confuse people more, or does that kind of make sense? Alright, just separate your things out very carefully. Just remember, C is not high level. It doesn't know, it takes things in a certain order.
So it's always going to be true.
This will always be true, yes. Always. Because it's going to be something or true, which is always true. Alright, let's see, what time is it? Okay, a few minutes. Switch statements, I'm going to let you guys do. Is there anything? Okay, before I leave, I'm going to make a few comments about debugging code because you are starting to write things that are going to probably not work the first time you write them. In fact, I don't know if you guys have seen the new homework. I think it's up. It's nice and confusing. I saw. Not straightforward. It's kind of weird, to be honest, which is good, because then people will have to think a bit. So you're gonna run into problems now. Things are gonna be happening in your code, and you're gonna want to go to office hours and just tell me, I wrote this and it should work, but it's not working how it should. Like something's broken, not my fault. First off, yes, it is something you wrote, but you need to learn how to debug your own code and figure out where these errors are, because it's not helpful to you if I just go and tell you exactly what's wrong with your code. You need to learn how to debug your own code. Something very useful. So, some hints. Use the dash wall GCC option. That turns on all warnings. So, normally the compiler GCC will only tell you stuff if you have a compiler error and it doesn't compile your program. So remember, when you have a compiler error, it doesn't actually give an output. If you have an a.out and you compile it and it gives you an error, it didn't change a.out. However, so usually GCC only tells you when there's errors. But if you turn on dash wall, it'll tell you a bunch of other warnings. Like if something in your code looks a little bit weird, like even things as much as when you don't use a variable, it'll tell you such.
How would you literally type that into the program to get the warnings?
Okay, so you say GCC -wall -std equals C99.
But that's just a command, right? I mean, is there a way to put it in the program?
What do you mean?
I mean, you're just asking it to compile and use dash wall, but can you,
It's a compiler option. It's telling GCC how to run.
Yeah.
So I don't know. I don't know if there's some way to make C code to tell it to turn it on, but come on. If you type out GCC the big line one time, all you got to do is if you're in PuTTY or even in Lab, all you got to do is up arrow, down arrow to go through your previous commands. You only have to type it once. So just use standard equals C99, use dash wall. You'll probably get some useful information. My next hint is when you have compiler errors, and output and warnings and such, read them. People usually come to me and say, I got this compiler error, but I don't know what that means. It's usually pretty descriptive. It'll tell you what line the error is on. A lot of times the error is before the line, like say you forget a semicolon on line 13 and you have a comment in line 14, you have code in line 15. It'll tell you line 15, character 1, expected semicolon or colon or something before this printf statement. It's because you didn't put a semicolon on your statement 2 lines ago. Anyways, read the errors. They're usually pretty descriptive, and after you see your error, you're like, oh, I get what they meant. And if you don't get them, don't figure them out, use Google. The other thing, if you get a segmentation fault, that's a nice scary error, that's a runtime error. It usually means that you are trying to write to memory that doesn't exist, or you're not supposed to be. At this point in time, before you're doing arrays, usually you're going out of the bounds with arrays, but at this time, you probably or just forgot your ampersand on your scanf. And the last thing I'll say is when you're having problems in your code and you don't know why they're happening, start printing out your variables. Trace your code out. Like, if you're doing this crazy modulo thing and you're not understanding what's going on, print up all of your variables out, at intermediate times in your code. If you're wondering if your if statement is actually executing, put a printf, like printf, number 1, to know that like it actually went into that if statement. Print out your variables, print out things, debug that way. Figure out what your program's doing if you don't understand why it's not working. Trace it through. Watch your variables change, figure out what your program's doing. And if you comment your code and you keep it clean and you name your variables right, it'll be a lot easier.